Welcome along to part 1, how we're going to build and take measurements for our capacitor charging circuit. So first of all, we need to assemble and build our circuit. We need to get a supply. There's multiple methods of getting up, select a component. You have obviously your shortcut keys along the top. You can actually go to place and then component, and it also tells you the shortcut is Control W, which you can press on your keyboard to get the same place. Depending on which one you click up the top here, you get different elements of this. So if you go to basic here, it's the same as pressing basic up there. Or if you go to your diode, it converts it to the diode section of the drop down menu. The first thing we want is a DC power source. We're just going to place it in. We'll relabel and give values later on. We need a ground. We need a capacitor, which is under basic. Down to capacitor. We are going to use a 5000 ohm or 5 kilo ohm. You can either do 5000 or type in 5k, does the same job. And we'll place it somewhere about there. We also need a capacitor, and the one we've selected for this one is going to be a 10 microfarad. You can type in microfarad, the shortcut for it is U. And we obviously don't have a micro button on our keyboards. We also need a switch as well, and the one we want is one thankfully highlighted already, but go to switch, scroll down a little bit and you find single pole double throw, and we need to orientate it by 180 degrees to be like so. You can change which key activates it if you so wish by the drop down menu. Double click on the switch itself and change. For instance, if you want to press A instead of it. I'm pretty happy with space and leave it alone. I still need to change the value of the DC supply. It comes as default by 12. In this one we want to change to 100. Just double click on it, highlight the value of voltage, type in your new value and press enter. You need to connect up the circuit. As shown. And obviously place in your ground connection as well. There's also this sort of internal loop we want to do, like so. That creates now effectively two circuits, depending on which ones you're going to have the switch position in. So in this position here, it's going to charge. The supply will be across the capacitor and resistor, and it's able to charge up the capacitor. In this position, we basically create a shorter circuit around this area here, through the space section here, and obviously still the capacitor and resistor. And then effectively the battery, or the power supply to the system, is now no longer really part of it, as it now ends here. So that is the first initial build. From there we need to get an oscilloscope. An oscilloscope on my particular one is the fourth item down, and we want to place it onto our screen, and you need to connect it up. So there's two channels in this particular one, A and B. Take the left hand side of A and go in between the resistor and the capacitor, and then it needs a ground as well. You can either just go directly into anywhere on the circuit that's ground. Some people prefer to go a wee bit closer, for instance down to here, or you can also, if I copy and paste, you can put its own dedicated ground in as well, like so. Either one of the three does exactly the same job. At this particular point, we're ready to try and start collecting data. For the purposes of the video, to avoid any audio issues, I'm going to record these on a separate sheet and then transfer them onto Excel in a little minute. So let's see how we collect data. The first thing we need to do is actually run our circuit. Now I'm going to try and make this as large as possible for you to see. See a tiny bit of the circuit. So we have our space which we need to operate, and I want to be able to access this play button. So when I hit play, obviously the oscilloscope comes alive. You see the red line going across the screen, which is effectively showing 0 volts, because the switch is currently in the sort of closed position, if you will, for it's not able to charge up. Typically prefer to witness this. I know that my capacitor circuit is going to charge up to whatever the VS supply is, which is 100 volts. So I want to be able to witness that. So I want to change my channel I divisions to increase them. So that means every dashed line you see here is now going to be, in this case, 20 volts. So that'll be 20, 40, 60. It's still going to be outside of my scale. I want to rise it up so I can actually see everything. So now I'm going to have 50, 100, 150. I know mine's going to 100, so that's obviously satisfactory enough for me. And at any particular point, I'm just going to press the space bar and we're going to witness the capacitor circuit charge up. Okay, so it looks kind of shallow, and we can change that by changing our time base. And what we want to be able to witness is the point at which it flattens out in around 100 volts and levels off. Give it a few extra seconds to run after that, and then we're able to stop the circuit. Okay, so all I'm doing here is playing with my X time base, and once I'm pretty confident it's leveled off, so just one final wee step there. Also notice that the transition time, or the simulation time, is still only at 0.7 of a second. You see it down the bottom. So it's not a 1-to-1 ratio for time. Pretty confident that's leveled off. I can stop that now. And now I'm looking to take readings from this. Now, as part of what you'll be doing, you have to take readings at various time points. The time points in a circuit like this, yes, they have an actual value, but they're actually generated by the tau, or the time constant. So what I want to take measurements of is at 0, half, 1, 1.5, 2, 3, 4, 5 and 6 tau. So that's, for instance, half of the time base, or 1 times the time base for the time constant. So to get to our initial starting point, you want to try and get that cursor as tight as you can into where you started the circuit. The easiest way to do that is to leave your cursor typically left hand side, right click, set the Y value to the right, and you want to pick a very, very small number, like so. And when you do that, it picks up the very, very first point at which the circuit begins to rise, the voltage begins to rise across the capacitor. And that gives us a really good starting point in time of when I pressed the switch. Now I want to record that time. I'm just going to write it down separately here. So 375.883 milliseconds. Now I want to increase the time for each step, so I can measure all the particular locations. And to measure each of the locations is pretty straightforward, and all you need to do is go into set the X value, and it tells you where it's currently at, and I want to increase that value to the location that I want to measure. So on our particular circuit, we need to find out something. We need to find out what our time constant is. So our time constant, so that's tau, is equal to C times R. So the capacitance value was 10 microfarads, which is 10 times 10 to the minus 6, multiplied by the resistance value was 5,000, or 5k. Now if you do that in your calculator, so that is 10 times 10 to the negative 6 multiplied by, and then 5 times 10 to the positive 3 for 1,000 is 0.05, and that there will be measured in seconds, or that is equivalent to 50 milliseconds. So that means for each time constant we want to increase this value by 50 milliseconds. So the very first one therefore is 375.883, and we can add on, the first one we want to measure is actually half of tau. So half of tau will be 25 milliseconds. So add that on, we should have 400.883. And you see the cursor now moves to basically what is the half tau point. And I want to record that value, which is 39.341. And that's measured in volts. Okay, so that's your half tau point. I want to now go to 1 tau. So again, go to your X and set your X value. I need to increase that by another 25. So I've now in total increased my original number by 50 tau, which is or 50 milliseconds, which is 1 tau, which is 1 time constant. So I press enter on the keyboard and I see my cursor moves to that particular point in time, which is 425.883 milliseconds, and you see it's at 63.209 volts. 63.209 volts. I also need again 1.5 tau for my table. So I need to increase that again by another 25 milliseconds, which will increase my line to 1.5 tau. That takes me to 77.685 volts. The fourth reading I require will be another 25 milliseconds. So that will take me all the way to 2 tau. So my original was 375.883. I'm now going to 2 tau. So it's now going to 475.883 milliseconds. Press equals, and now I'm able to get 86 rather. 86.465. And for each of the time constants, you just keep increasing or adding on from whatever your original value was. The big idea with writing down your original one is in case you accidentally move that cursor, like what I did there, it means you can go to your X value and you can type in the original number you had. That takes you back, if I typed it in right. I forgot to put in the milliseconds, so 375.883. Remember to put in your M for milliseconds, and it puts it back to the start for you. So I want to take one more reading, I'll show you, which is the 3 tau point. Is my next reading I want to take, which is 0.15 seconds from the original, or 150 from the original. So that's 375.883, and we're looking to add on effectively 150 milliseconds, which is going to take me to a value of 525. So 525.883 milliseconds, and I get 95.201 volts. I've only got 3 readings left to take, so I'll continue to take these, but I'll take these off video to stop wasting more time.